called Writing Across the Curriculum, in which schools are encouraged to have kids write in classes other than English. You know, other than your English class, are you writing anything? Secondly, I don't know if you know this about me or not, maybe I already told you, I'm an English major too. So I'm a certified English teacher. I student taught English, but then when I came to Cathedral, there was an English job and a math job. I applied for both of them and got the math job. So I've not taught English since my career began. But I still love to write. I do a lot of proofreading for people. And so what we're going to write is an essay. Now, before you start panicking, first of all, we're going to make one thing real clear. There's no research involved. This is about you. This essay is going to be about you. So there is absolutely no need for you to plagiarize, use AI, anything. This is about you. It is one typewritten page, double spaced. It is due in 6 weeks. Okay? I'm real clear. You will submit to turnitin.com. That's worth 5 points, by the way. This whole thing's worth 25 points. So you turn it in, and you're gonna get 25 out of 25 if you follow the rules. So what are the rules? What is this thing about? Well, it's due right before Thanksgiving. Thanksgiving is a time to be thankful. So I want you to think, dig deep. What is one trait you possess that you are proud of? So maybe you're a good big sister. Maybe you are a good track athlete. Maybe you are a good listener. I don't know. Or maybe you're loyal. Maybe you're a good leader. I don't know what you feel about yourself. That's what I want you to write about. So, the trait I'm most proud of is my leadership skills. I have demonstrated leadership by doing X, Y, and Z. By the time you explain how you demonstrated leadership or how you demonstrated being a good brother, by the time you've done that, your page is full. Okay, it's 1 page, you guys. Now, you can write more if you want. It's a minimum of 1 page. And what is it about? You. Something about you that you are proud of. Don't worry about writing about yourself. This is what I want you to brag about. Something about you that you are really proud of yourself for. Because you all have probably lots of things to be proud of, but you all have at least one. Somewhere in there, there's something you're proud of. Okay? Thinking about that? You can turn that in. I think I opened up the turn it in window on Friday. So starting Friday, you can write this. There's nothing to wait for. It's due, I think, the 17th of November. Double check that. It could be wrong. That's about when it's due, the Friday before Thanksgiving. Doing hard copy form. Hard copy. I'm old school. Don't be sending me electronic stuff. I won't read it. I need a hard copy. Printed. Turn it. You'll put it into turnitin.com before the due date, or you get a 0. Okay? You also get a 0, no rewrites, no second chances, even if you plagiarize in any way, shape, or form, and that includes AI. You don't need it. This is about you. Every year, I do a spring essay too. We do one in the fall, one in the spring. Every year, somebody plagiarizes. How do you plagiarize about you? I don't know, but they do. Okay? And there's no discussion about it. It's 1 page. You get 25 points, test points. Okay?
And you said double space, so
MLA format, absolutely, MLA format. So by the time you get your heading on there, I mean, we're not talking a significant paper here. We're talking something small that you can do to show off something about yourself. Got it? Everybody clear on that? Okay, so make sure you look at the description in Schoology and ask me any questions before the due date, because I'm holding you accountable for the directions in Schoology, which we just kind of talked about here. Read through that, do what it says, and everything will be fine. Turn it in anytime you want before the due date. Okay? Alright. By the way, 1 page, 6 weeks. How lenient are we going to be about late papers? We're not. We're not. You wanna get a 0 out of 25, turn it in late. Alright, come on, get it done, and done soon. Perfect. Okay, let me fix Leslie's attendance, and then let's get started on oh, and just one more quick word about this. I read every word that you write. So this isn't something that you turn in and everybody gets 10 out of 10 or 25 out of 25 or whatever. No, I read every word. So you're gonna get your paper back and there are gonna be things underlined. There are gonna be little comments made over here. You're gonna see a ton of stuff because I stay focused by annotating. You know what annotation is? You do it in English. That's what I do with your papers. I will read every single word that you write. Okay? Now, I'm not gonna be I am a grammar freak, I'll be honest, I am. But I'm not gonna penalize you for it unless you do something like turn in 1 sentence, so the whole paper is one big run-on sentence. Okay, you know better than that, right? That you're gonna lose a couple points for. But if you misplace a comma, I'll correct it, but I'm not gonna take off points for every little grammatical error. Okay, I want this to be your writing. Yours, from your heart, about you. Okay? Alright. I'm always excited to read this. Alright, so we are ready now for problem 5 on the word problems. Practice test 2, number 5. Tuition's 11.8, and it's going to 12.2. And we need to find the percent of increase. Alright, who remembers how we do this? So it's the difference minus the original, or the change, difference minus original, or not difference, new minus old, not difference. It's different change over original. So difference over original, change over original. So how much did it change? How much did it go up?
Wait, you
Yeah, of course you subtract, right? Finding the difference. What?
4,000.
Not 4,000. 400. Because you can do that on your calculator. If you can't do it in your head, you've got a calculator. Use it.
Yep, 400.
And then over the original, which is the starting amount, which is 11.8. Now, when you type this in, you are going to get 0.03389830, it keeps going. Now, your job is to find the percent, right? So we're gonna have to move that 2 places. So it's gonna be 3.389830, Would you agree with that? Move it 2 places and get the percent. Now we're gonna round it off to the nearest 100. So that means we either keep the 8 or we make it a 9. So what's gonna happen? It's gonna go up to a 9. So your answer is 3.39%. Okay? Got it? All right. Now we've got this picture. And we want to know all this stuff about it. So while I'm drawing my picture, would you see if you can answer A, B, and C? A, B, and C. You're gonna answer those questions. Alright, so did you answer A? What did you say? Is that picture a function? Passes the vertical line test. So yes, passes vertical line test.
3.39%.
Is its inverse a function? No, because
Doesn't pass the horizontal.
doesn't pass, or I'll say fails, the horizontal line test. This is the horizontal line test. Look. See how if I draw that horizontal line through, I hit over and over and over again? That can't be. You only want to hit one time. So what does that mean about 1-to-1? Is it 1-to-1? No, because it must pass both tests. And since it doesn't pass both tests, it is not 1-to-1. And then we need to sketch the inverse. So this is very, very easy. Very easy. I would recommend that you do what I did, which is just label all of your original points. Because when you sketch the inverse, what are you gonna do? Flip them. So instead of plotting -2, 0, you're going to plot 0, -2, which you can label or not, I don't care, doesn't matter. And I don't even care if you label these, I just think it's a good idea to label them. Alright, instead of plotting -1, 2, I'm gonna plot 2, -1, and then 0, 0. It doesn't change. So there's my first piece of the inverse. Well, 1, 1 isn't gonna change. But 2, 0 is going to become 0, 2. There's the next piece. And then -1, 3. And -1, 4. And 0, 5. So when you graph your inverse, should it be the same shape? Yeah. But instead of being situated on the x-axis, it's now situated on the y because you switched variables, right? Doesn't that make sense? I mean, that's what you did. You switched the variables.
Will we have a place to sketch it on
Yes.
the edge?
Yes. When we get to practice test 3, I formatted that more like the actual test. You'll see you got.
Okay.
Okay. All right, number 7. Now, we're going to find the inverse of this equation. Have we ever done this before? Yes, in fact, this is what your quiz was like. Remember that one problem quiz you took? This is what it was like. So what do we do first? So we'll just make that a y equals. And then we'll make it x equals, because we're gonna switch the variables. Now, do you know what to do?
Yeah.
But we multiply to
bring this over here, right? So it's gonna be a distributive. Perfect. Now what? This is where we sometimes get messed up. Jared?
You subtract the x and subtract the y.
These guys right here have to switch places. And since they're additions, they're gonna become subtractions. So 2yx minus 3y and negative x minus 8. So just the middle two here move to the opposite side that they're on. And when they move, they change sign. So if they were a plus, they become a minus, and vice versa. Now what?
Take the y out.
Take the y out, factor out the y. So we'll have 2x minus 3, and then negative x minus 8. Okay. Divide by the parentheses. And when you divide, guys, I remember on your quizzes, some of you were flipping these. No. It's gonna be negative x minus 8 over 2x minus 3. Because 2x minus 3 is what you're dividing by. And then we'll change it back into our function notation. And there's your answer. Okay. Josh, you got this? You're kind of just sitting there.
No, I'm ready now.
Okay.
Like, I did it before you.
Oh, good for you.
Yeah.
Okay.
I don't know why those come to me, because we practice them so much.
Good.
Office
Good.
hours.
It's amazing how when you practice something a lot,
I still got a 9 out of 10 on office though.
oh, who knows? All right. I'm gonna go ahead and make my f of x and y. Is that okay? That's the first step, right? I'm doing another problem just like the one I just did. This one's easier though. So there's, that question's on the test, this question's on the test. There's one of each of these on there. So we gotta find the inverse. Okay? So what do we do here? I've already made that a y. So now I switch my variables. You gotta remember to switch your variables, kids. That's how you find an inverse. They flip-flop. Then we'll multiply by 4.
Then you put the 8y over and then the 4x on the other side.
Well, I don't even need to do that. I could,
Oh, you could just do
but that's more work than I need to do. Don't I just add 3 and divide by 8. And change it back into the inverse notation. Don't make this hard, guys. This is like regular equation solving. So we want to get y by itself. So we multiply the 4 over, add the 3 over, and divide by 8. Just like regular solving. Okay? As you are preparing, you might just want to copy those down on another sheet of paper and be like Josh and practice. All right, what happens here? I got two functions, f and g, and the question is, are they inverses? Are they inverses? Well, we did one of these yesterday, or someday. Do you remember kind of what we did? What did we talk about? But we'll just pick a number. What number do you want to start with? Don't use 1 or 0.
3.
3? 2? Oh, we'll add the other. How about 5? Okay, it doesn't matter, we'll just pick a number, we'll use 5. So I'm gonna put 5, any number, not 1 or 0, any other number. I pick 5, and I'm putting it into this function. What do I get when I put 5 into function f? 13. Now I'm gonna take that 13 and put it into the other function. If these are inverses, what's going to happen?
The number that you put in will come back out.
Exactly. The number that you put in originally is the one that will come back
And it
out.
does.
And it does. 13 minus 3 is 10, divided by 2 is 5. Are these inverses? Yes. Because why?
When you put in a 5.
When you put in a 5,
A 5.
you ultimately get a 5 back again. Okay, I can live with that. That's an example of an explanation.
What's the
And what did you say
ideal
again?
explanation?
What did you say again?
I just,
No, you said it earlier. You get your number back out or something. What did you say? I don't know. Because,
is it right though?
yeah, f of 5 is 13 and g of 13 is 5. That's what it means to be inverses.
Just plug in 5 for the bottom one,
Okay, I'm not plugging in 5. 5 goes into the f,
That's 4. 7 minus
and I get an
2
answer.
is 2.
The answer goes into g.
I literally think you typed it as wrong. Your calculator. Oh, it's because you divided by 2.
Somehow in your explanation, you guys, you have to explain that the number you started with is ultimately the number you ended with. If it's a yes. If it's not, then you didn't end up with the number you started with, right?
This one, so the way we explained this one, because it's when it was an inverse, can we just put 4 if it was a no, because f of 5 equals this, and g of 13?
Exactly.
Okay.
Exactly. That would be perfect. That would be perfect. All right. This one, number 9, is the easy question. You are finding x and y. We know that x is 2t plus 1, we know that y is t squared, and we know t is -2. What do?
put in the T.
Plug it in. Plug it in. Our job is to find a point. Find an ordered pair. So how do we get our x value? We plug in -2 right here. So what is that?
So, or x is -2, right?
No, x is not -2.
-3.
-3.
Yeah.
And then did you put negative
And then we put -2 in here, and y is
4?
4. There it is. Plug it in. To find the values of x and y, that's what you're doing. You're finding an ordered pair. You're finding x comma y. You just plug the number into the equations.
That should be.
Nobody better manage to miss that, or I'm gonna just,
They'll probably be me, sorry.
don't even think about missing that. That's easy, just plug in. Now, we've got kind of the same given. We've got a couple of equations here. But this does not say, find x and y. I don't see anywhere, it doesn't say anything about an ordered pair. It says find a direct algebraic relationship between x and y. Who remembers what that means? Eliminate the t's. I need to eliminate the t's. Now, if I look at, I'm gonna rewrite that second equation so it's 0 plus 1/2 t. That might help you see a little better. If I add these together, if I add these together, these do not cancel, right? Right?
Correct.
Okay, so what you wanna do what could you do? You got more than one option. What could you do to make them cancel when you add it? Now, one's negative and one's positive, so that's good. But I need them both to be the same number. So what could we do to make them the same number?
Couldn't you multiply the bottom by -4?
Do what?
Could you multiply the bottom by -4?
Okay, by positive 4.
Or positive?
We could multiply the bottom by 4 because what has Mackenzie noticed? What is 4 times a half, you guys? What's 4 times a half? 2. And isn't that what you wanted? So Mackenzie didn't get freaked out by the fraction. She said, okay, 1/2 times 4 would give me my 2. And if she couldn't do that in her head, she's sitting there with a calculator, right? She could do 1/2 times 5, 1/2 times 4, 1/2 times whatever she wanted to try to get the right number. Now they match. Now I add x plus 4y equals 4, problem finished. That is the direct algebraic relationship between x and y. So again, eliminate t. For that problem, we eliminate t. Now I think Tegan was gonna divide this by 4, divide the top one by 4. That's legal. It is gonna give her a fraction here, but that's okay. That's all right, that would work also. Your equation will look different, but it'll be the same answer.
Can we use substitution instead?
Absolutely, you can use substitution. Absolutely, you can always substitute. Do you remember when you solved systems back in the day, you had substitution and elimination? Yep. I have chosen elimination because it's usually the easier, but in this case, certainly you could substitute if you want. Yep. Okay, and then we got the hard problem. We gotta figure out what changed in getting from figure 1, so look at figure 1, look at figure 2, and has anything changed? Well, yeah, clearly. What are some things that have changed? So it's upside down? Kids, look at it. In the original picture, that would be figure 1, isn't the triangle pointing up? But in figure 2, it's pointing down. Doesn't that mean I flipped it? Upside down?
Using the sideways flip.
Okay. No, it's not a sideways flip because isn't the triangle on the left side in both pictures? So there hasn't been a flip sideways.
The height?
It's bigger,
It's taller.
so is it twice as big?
Yes.
Alright, so it's twice as tall. The height is it's 2 times the height. And it went down 2 because the original was sitting right on the axis. And this one is down 2 and -2. Okay, wow. Now you gotta write an equation. There's the basics of it. And you gotta stick numbers in. Okay, so what's gonna make it go upside down?
Negative.
That's like
A negative out here in front. Okay? What's gonna make it be twice as tall? A 2 right here is the height, guys. That's the height spot. And then how do I go down to? -2 on the end.
outside, yeah.
That's where we put them. That's where we put them when it goes down to 2.
But then, you have to put something behind it. Or you don't have to put something behind the X.
Only if it moves sideways. Did it move sideways?
So it's done.
It's done, that's it.
You already did 3.
So as soon as you do these 3 things in your equation, the negative, the 2, and the -2, we're done. We did it all. Okay? All right, one more. Here we go. Practice test 3.
Love calculation. This is for you aren't.
Huh?
You are.
No, no, I hope so. She's gonna do it right now.
Alright, so here we go. We have already done this just a couple minutes ago. Notice, by the way, I put your answer blank. See your answer blank right there? Just like your test, and I put the function notation there to remind you at your answer. Alright, 4x plus 7, here we go. What are you gonna do? Make it a y.
And then switch the x and y,
Switch the x and the y.
and then subtract the 7
And then we're gonna get y
by
by itself. So we'll start by subtracting 7 and divide by 4. So in the answer blank where it says F inverse, you're gonna write x minus 7 over 4. You need to practice this on your own, people, because I make it look easy. That's my job. It's my job. You have to be able to do it by yourself. And actually, that is easy. That is an easy one. You have to. Okay, so now I've got g of x. Now, does it matter what I name my function? No. So I called this one g. It doesn't matter. I'm going to change that into a y anyway, right? So it makes no difference whatsoever in how I do the problem. I could have called it H or P or Q, whatever. So now we make it x equals. And then multiply this over to here. And when you multiply this over to here, it's gone from there. It's not there anymore. So 3yx plus 4x equals 2y minus 1. Then we do the big switch here. That's the step some of us forget sometimes. You've got to do that switch so that your y's are on the same side. So now I end up with a negative 2y or a minus 2y over here and a minus 4x over there. Okay.
Take out the one.
And then I'm gonna pull out the y. So I have 3x minus 2 and negative 4x minus 1.
And then you divide, so
And then we divide by the parentheses.
that's yours minus 2.
So we have this. And then we're gonna write it in the answer blank that has the function notation. Everybody okay with that? Okay? All right, number 2. Given this thing sketched at right, be careful, is the inverse a function? There's only one question there, A. Is the inverse a function?
Yes.
No, why not?
Because it doesn't pass the horizontal line.
Bingo! You guys, if the question is the inverse, if the question is about the inverse, we use the horizontal line test. If it's about the original, we use the vertical line test. This one is about the inverse. So the answer would be no. And your explanation would be, it doesn't pass the horizontal line test. Because the question is about the inverse, F inverse. Okay. Now I'm gonna sketch the inverse. So this is completely up to you, I've talked about that already today. But I would suggest that you write down what these original points are. It's a much, it's a simple little picture. What is this original point?
-3, 0.
Negative 3, 0. So it's gonna get plotted at 0, -3. What's this original point? -2, -1. So -1, -2. What's this one? -1, -1, so it doesn't change, it stays -1, -1. And so does the origin stay the same? There's your trapezoid. This point is 1, 1. It doesn't change. And this one's 2, 0. We okay with that? Okay, so how are you gonna sketch your inverse? You're not just gonna freehand it. You're gonna take each of the points of the original, flip them, and plot them. You can't miss if you do that. If you try to shortcut, try to get lazy, then, yep, probably gonna miss it. But if you do every point flip-flop, connect the dots, you'll be fine. Create your own function that is not 1 to 1. Okay, so you need to come up with a picture. Everybody take a minute and do it, because there's lots. You could all have different ones. Draw a picture that's not 1 to 1, which means what?
It doesn't pass both.
It doesn't pass both. It can pass one, but not the other, right? So draw something that you think is not 1 to 1. All right, and let's get 3 of them up here on the board. So who's got one to draw? Okay, Wyatt, who else got one to draw? Okay, Lucy and Keegan. All right, so come up and draw your picture that's not 1 to 1. All right, let's take a look at these. Thank you, guys. Let's take a look at them. They're all different. Good to see. Thank you. Yay, good job. I think they're all okay. Would you agree? None of these is 1 to 1. Because while they all pass the vertical, none of them passes the horizontal. Okay? So anything you draw is okay, as long as it, in this case, doesn't pass both tests. The question could say, draw something that is 1 to 1, in which case you'd have to figure out something that passes both tests. Like a line, or a logarithm. number 4, here we go. Number 4. What is my job in number 4? Read the problem. What are you looking for? X and Y. You're looking for the values of X and Y. So what are we going to do? Plug in whatever they tell me to plug in. And in this problem, they're telling me to plug in -2. So go ahead, put -2 in here and tell me the X and the Y that you come up with.
-5 and
No, we're not gonna miss this problem, Josh, try again.
-4. I'll just off the top of my head.
Okay, well, don't,
I mean, obviously, I'm not gonna do
11
that.
and 4.
okay, what'd you get?
11 and 4.
11 and 4.
Okay, I got the second one right.
Okay, we got 11 and 4, everybody? Cause we put in -2. And oh, by the way, can we use our calculator if we can't do the math? Yes? Okay, number 5. Find the direct algebraic relationship between these guys. Now, when I copy my problem, I'm gonna copy it like this because I know what's coming. Find the direct algebraic relationship means somehow I have to get rid of my t. So I'm gonna line them up. Put a 0 in here. Okay with everybody? Now, these gotta cancel. They don't right now. If you added right now, you get 19. You need them to cancel out. So what is one thing we could do? You have more than one option. There are lots of things we could do, but what's one thing we could do? Multiply the bottom one by -2. The top one stays the same. And then -2y, 0, -16. Is that gonna do the trick? Yep,
Is that? Like a -2.
as opposed to what?
Like,
What did you want to multiply?
just the number.
Well, I need these to cancel.
Oh,
So how do I
okay.
turn a 3 into a 6? Yeah.
And then once I take away the t, do we want it to be in like where x is by itself or not? Or no, y is y by
Nope,
itself?
this is fine. This is fine.
Oh, okay.
That's fine. You can, that's a line, so you can absolutely rearrange things and put it in slope intercept form if you want, or something like that, but you don't have to. You don't have to, that's good enough right there. Okay, these don't get combined, right? They stay separate terms, x minus 2y. They're being subtracted. Oh my, now we have the hard one. Alright, so look at it carefully. And I would suggest that you make a list of the changes you observe. So what are some differences you observe in the problem? Yep.
1B bottoms up.
Well, it's true that everything's above the axis, but bottoms up would have, okay, so this part would stay exactly the same if I were doing bottoms up. And then this would come up, and this would come up. Now, is that what happened? So I don't think that's it.
Went up by 1.
Up by 1, has the whole picture been lifted up 1? So that, Daryl, brought everything up above because I just physically picked it up. What else did I do to it? I think there's another change.
Isn't it flipped?
It's flipped sideways. Look at it carefully, guys. Do you see the triangle that's originally on the left? Isn't it now over here on the right? And the little Nike swoosh backwards thing here is now over here. So, we have done up one and sideways flip. So your job is to write the equation, and what you're gonna write, I wrote y equals, you're gonna have f of x. And now modify that. Okay, what are you doing? How do we make it up one? Add the one at the end. How do we do a sideways flip? Change the sign on x, put a negative on x. That's how you do a sideways flip. So that's the answer to the question. So when you do this problem, you're gonna start with y equals f of x. That's what you're starting with. Then you're gonna put into that anything that you need to put in to change it the way you thought it needed to change. Are you with me? All right, now we've got this one. Are these things inverses, y or y not? Okay.
Wait, was it just find the inverse and then just say if it's the inverse?
You could do that. That really isn't a proof though, so I prefer that you not do it that way. Okay, so here they are. We want to know if they're inverses. So what do I do first? I pick a number, right? Pick a number out of thin air. Let's go with something crazy. How about 17? Okay, so f of 17 is what? Now you have a calculator. If you can't do this, it's fine. Put 17 in here. What comes out?
30. No. 31 minus 5. 29.
29. Now, take the 29 and put it into your other function. If this is going to be a yes, then that better equal 17, right? So let's see, put 29 in here. What's 29 plus 5?
31.
Divided by 2. Bingo. So we got ourselves a yes, right? So we'll say yes. Because, and then in your own words, describe what just happened. So if you want to, like Daryl, he wants to use the numbers. Because f of 17 equal 29, and g of 29 equals 17. That's good. Josh might want to use words and say, when I plug 17 into f, I got 29, and when I plug 29 into g, I got my 17 back again. Somehow explain that this is what happened, or didn't happen. Because if they're not inverses, then when you do this, you'll get something else, right? If they're not inverses. Okay. All right. So now what? What's next? That's the last one.
Box problem.
What do
Or
we have now?
the one the special problem.
Well, we have our word problems now, right? So here we go. Let's get the box done, and then we'll be done for the day. All right, so this time our paper is 20 by 12. We're gonna cut the X's out of the corners. Our clock is a little bit fast, so we should be okay. So cut the corners out. All right, tell me what my equation is.
2x.
So y equals 12 minus 2x, 20 minus 2x, and x. One more time, you guys. Dimension minus 2x. dimension minus 2x and x. Oh. Alright, now I need my domain, which is essentially my x min and x max.
Should be 0.6.
0, 6. Kate, you're exactly right. How did you do that?
What was always gonna be 0 for the
Always
x,
gonna be 0 for the mins.
and then you can just half of the smallest.
Half of the smaller dimension. The smaller dimension's 12, half of 12 is 6. Now, when you go to your calculator, this is x min, this is x max. What are you gonna put in for y min and y max?
Everyone.
Always 0 for the min. And then, I don't know, we've been using 200, I don't care, we can try 200. Sometimes we have to adjust that, right? But we can start with that. So go to my equation, type that in. You already do this, Tegan?
Yeah.
Alright, we're calling you for the answer then, here in a second. Oh shoot, was 200 big enough? No, I think I'll make it 400. So everybody gets why I had to make that adjustment, right? So second trace, maximum, enter, left bound, enter, right bound, enter. Izzy, why are you watching the clock? Have you already done this problem? Math is not a spectator sport. Okay, what is our maximum? What did you come up with, Tegan?
262.68.
Okay, so we got x was 2.427 and y, but then I'm in the hundreds, so I'll say 43. And y is 262.68. So on my calculator, it literally says maximum, the word maximum, and then it has these two numbers. If the question is, find the maximum volume of the box, then the answer is 262.68 cubic inches. If the question is, how big a corner should I cut out, then the answer is 2.43 inches.
Is it inches cubed or just inches?
Now, this would just be inches. This is me.
Let's go.
All right, we'll finish this up on Friday.